goodbye.
We need to mix up our intro music. How's everyone doing this morning? How are you, Ilya? Okay, we can get started. We have a lot of bots listening into the call. Welcome everyone. Welcome to today's Tori Tech Talk. I had some people message me that they'll join in a little bit as well. Yep, we're here from Tori. We help sales agents at hotels using data science and AI. Our CEO Jason was telling us earlier this week about someone who came up to him, and they were trying to book a wedding for their daughter, and they spent weeks and weeks and weeks trying to get a venue, and they weren't able to do that because the sales agents at these hotels are just so overworked. And that's where we come in, and we help automate a lot of the processes and the workflows of these sales agents. So that's the context of how we use these systems. Yep, so this is Jason, our CEO, and if anyone's interested in helping us out with our various workflows or media requests, let us know. And then I'll kick it right over to you, Addison.
Alrighty.
I refuse to use your yearbook photo.
That's fair, that's fair. I know that photo's from so long ago. Oh yeah, so today I'm going to be talking about this paper called refinement query.
Do you want to share your screen?
Yeah, I was gonna say I also have a presentation up and ready to go. Let's just see if we can pull this up correctly. Slideshow mode, beginning. Can everybody see this?
Yeah.
Okay. All right. Let me just minimize that zoom. See. All right. Looks good. Alrighty. Yeah. So obviously RAG has been a kind of major advancement in terms of allowing LLMs to look back on either private information that isn't just something you could fine tune on, or also just data where there is no great way of having it processed in. It also does a great job of allowing these LLMs to look specifically straight back into their context window versus having to kind of rely on something that has been trained on. So it's definitely a great system, and I'll kind of give a very quick overview of RAG right now. Essentially what you have is a prompt comes in from the system or from the user, from maybe some Q&A database that you're going over. It's like how it comes about doesn't matter too much, but then you'll have a vector database, which you build by essentially grabbing all of these documents that you'll have. You know, maybe this is like all of Wikipedia, or, you know, for Tori, it's kind of more of, okay, well, what is relevant to all these hotel salespersons that we work with? And it can range definitely quite largely, or maybe just like a bunch of books. And each book, you essentially will then take the metadata from it, have this metadata, run it through a vectorizer, which essentially creates a very easy to understand location of it based off of what is actually contained in this. So you kind of think like if you have a book that's solely about dogs, maybe there's like a specific dimension within your vectorizer that is correlated with dogs, and that dog vector will go up so that whenever you have a query that comes in that is related to dogs, you'll be able to go and very quickly find this specific document. Well, it gets a little bit more complicated than that in terms of how you embed things, but this is kind of like a very high level overview of how you can then, once you kind of get your query from the prompt, you can go in, search for all these important documents, feed them back in as context to the LLM, and then the LLM will be able to go back and read through these documents. Maybe if you're asking something about dogs, to kind of maybe learn more about like medical practices or maybe specific facts about each breed, to then create a better response than if it had just solely relied on kind of what it had been pre-trained on. But of course, there are some downsides to RAG. First off, it's expensive to do, especially in cases where you don't even need to do it. So you'll see very quickly kind of a very easy example is kind of during first interactions with the LLM. They usually understand how to interact with their users. And there's no reason that you should be going into your database to kind of get an example of what a greeting should look like. Also, they can introduce unnecessary and confusing facts to the LLM. So if you have a poor setup where maybe there's a reason for some reason or not that your embedding is not actually capturing what it should be, you'll end up pulling out documents that just have completely nothing to do with what is actually being asked in the prompt. And this will then just cause the LLM to kind of maybe infer that the user is actually asking something different than they were because it has this context and it's learned that, okay, well, usually this context is important when in reality it's not in this case. Also, you have examples of like, if your database of previous knowledge is very domain specific to a certain domain, maybe you have just a list of basketball players and their stats. If you were to ask the LLM, well, what's the average height of a person? It might go into its database, say, well, look at all these players, look how tall they are. Obviously, the average person isn't nearly as tall as what the average NBA player is. And so in this case, you'll end up where it will hallucinate that whatever domain it's basing all of its knowledge on is the actual population domain that the user is asking about. And finally, yeah, as I've kind of touched on, the embedding of initial queries may not properly address what's being asked, or it may not properly address something that's actually in your database. And so to deal with this, these researchers out of Hong Kong and MIT have created a refinement query, which essentially they have taken a test database where they have a bunch of question and answer prompts. So they'll take a prompt, an answer for it. And then what they've really done, which is quite novel, is they have identified a refinement structure where they are able to take down these queries that you would give normally and then say, okay, well, so essentially you can break it down into three things. So first is the multi-turn dialogue. So essentially, we'll look back and we'll say, is it even necessary to use RAG here? Or can I just completely skip that step, save a bunch of time, and just begin immediately outputting things because this response is something that's already in my just kind of pre-knowledge. Then another step is the query needed is whether a query needs to be decomposed, which is essentially to say you might end up in a case where a query requires you to kind of look into two different questions at first. So you could kind of think of this as if you had like a database of personal relations between people and you want to figure out like who between, maybe it's LinkedIn connection. You want to ask like, okay, well, who could connect these two people that aren't directly connected to each other? You might have to first ask, okay, well, who of these people, who are the contacts of the first person? Like maybe it's, I'm trying to connect with Julian and we weren't like previously connected. We would look at, okay, well, who are all of Addison's contacts, and would ask who are all of Julian's contacts. And then it could be input. You would take the input of those two lists. The LLM could kind of find out, okay, well, who are the common links? And then create a plan of action for how you could connect these two people. Another one is query disambiguation, which is essentially you could ask kind of to it just based off the fact that like English isn't always fully specific, and oftentimes people will kind of be a little bit lazy when they're writing prompts. So you'll end up with kind of questions that are asked that don't really have a clear subjective answer, kind of like a more open-ended question where you can kind of take the question both ways. And so the idea is, well, to actually answer both questions correctly, I might actually need to generate two different queries that I run and I send over to my vector database. And so can I branch this out, say, okay, well, this first query is kind of not really great because it's only asking one of the two ideas. So here I'll go create a second or maybe a third, or however many ways it could be taken. Essentially, the researchers have then done all of this. They use ChatGPT a little bit to help themselves out in identifying what are the best steps at each location. I'll go into these prompts that they give ChatGPT to generate an idea of what the better query is. Once they do that, they end up with like a very large kind of fine-tuning data set, and then they feed that into a 7 billion llama model so they can kind of directly examine how well it works, and also can show that, to have these major improvements, you don't actually need to have that large of a model. And you'll see that I compare it off to GPT-3 and GPT-4, which are obviously much bigger models than this 7 billion llama 2 model that they use. Alrighty, so how is training data labeled? So you'll see here are the kind of 3 different system prompts that they give based off of the whichever subset you're kind of sorted into here. And so the first one is, okay, well, in a multi-turn, or I won't read the entire thing, but essentially it comes down to this very last part, which is, as outlined, it is necessary to output retrieval necessity first. And the output should be one of yes or no. So essentially they're asking for a binary output from ChatGPT. And then they'll ask if the answer is yes, then give us, what is the better query for this if we are going to do a query. And if not, you don't need to provide that. Also, they should only ever skip the retrieval process if it's fairly confident that this is something that is already in its knowledge base. Then we have over here, it is looking into kind of decomposition tasks. This is specifically for multi-hop questions, which is essentially, well, how many hops in terms of reasoning do I need to make in order to like accurately answer a question?
Sorry, how do you reach the terminal state of that?
Yeah, so I'll go into what the terminal state is. Obviously, you would first of all have like a absolute terminal state where it's like don't do this more than like you're going to get yourself into an infinite loop. And we have like, every time we're doing one of these inferences, it's going to cost us some amount of money. And at some point you get diminishing returns. But also I'll show how they strategize in terms of when we're going through this, what should be our selection criteria for, okay, we're probably not getting to do any better.
And so,
And then
just back up just a moment and also explain what are some of the problems that this would be good at solving?
Yeah, so you could think of you would have like a question such as, so I talked about, if you're just asking the user says, oh, hello, how are you? If you had a database and your maybe vector database was all of these interactions between NBA players, you could end up in a situation where, hello, how are you is embedded as a query, which essentially goes and looks for like all of these instances where NBA players have come up and asked the same question. In like at the start of a press conference, and then just spitting out facts that were like followed up in a press conference, when in reality the user is just like doing like an everyday hello, which like it easily could have picked up on if it wasn't confused by all this context that was being randomly brought in. So understanding like in that case it's not appropriate to go and do all this RAG because you're just going to end up confusing yourself. Another example would be especially for this decomposition is if you ask like what college does Addison go to, or what type of university is the college that Addison goes to, you would first have to go into some type of database that has all these statistics about me. And from there, figure out, okay, well, Addison goes to the University of Maryland. And then you would need to go back in again and start up with another query to be like, okay, well, what type of university is the University of Maryland? And then in that database, you would figure out that, okay, well, this is a public database. Whereas you might not be able to initially find out if you just ask the question, what type of university does Addison go to? It's very unlikely that it's going to be in your database that I go to a public university, just because that's usually you would just store, the type of university that person goes to. And most people can kind of figure it out from there. But obviously for LLMs, which don't have all this common sense, just knowing that where I went to school, it's going to need that extra step to figure out kind of whatever stuff is needed. And then for disambiguation, you could have something where like I asked what was the most free throws made in the 2020 NBA season? And for that, there's kind of 2 ways of taking it. Do I mean which player made the most free throws? Do I mean which player made the most free throws in just a single game? Which team had the most free throws made? And so the idea there is, well, okay, the user was pretty ambiguous. I could either go into a conversation where I ask them for more context, or I could just answer all 3 of the plausible questions by essentially generating 3 different queries, one which will go and ask, okay, what were the most shots made by a single player over the season, over a game, or by a team? we'll do all three of those queries, get the answers, and then I'll combine this into a larger response that says, okay, well, here are the three ways I took your question, and here are the three answers for it, which is kind of a lot more efficient than, giving the wrong answer, waiting for the user to come back, re-explain themselves. And kind of, I think there's a very much better job of demonstrating just how powerful these things are, and that they are able to kind of navigate this ambiguousness. And it's also quite essential because it might like identify areas where your users didn't even know there were like other ways they could take their own questions, and you might even be able to give them knowledge that they didn't even think they needed. All right, so here's how to do inferencing, and this is kind of also what you're asking about, Julian, is, okay, well, how do I know when to stop? So they proposed 3 different ways for identifying when to stop. They're based off of these formulas you have down here. They're essentially the formulas for perplexity, confidence, and then at the very end, they have like an ensemble approach, which is they essentially just take, let's do everything. We're okay with having a really high cost. We just want to have the best answer, so we'll go with the best confidence at the end. Perplexity is essentially when an LLM gives an output, how surprising is this in terms of a metric? It's based off of the loss of the model rates to the exponential. It's a little bit complicated, but you just have to think about it as, okay, well, essentially how surprising is an output? And so what you can see going on here is for the perplexity, on this question, which I gave it as an example, you can see that the perplexity path essentially identifies that, well, actually, it would be the least perplexing to me if we just did not do any RAG at all, and I just went straight to my final answer. Whereas you might have a different case where for the confidence path, it identified, okay, well, I should do at least one query. So I'm going to do my query. I'm going to come down. I'm going to see, okay, well, actually, after that, that query was just enough, and I don't need to do any more type of inferencing. And I'll go straight out to my answer after that one query, and we're good. And then an ensemble approach is, okay, well, we'll just keep doing this for a while, and we'll take the best confidence score at the very end, which actually gives the same exact results in this case. But in some cases, you might end up where you short circuit on confidence at the very beginning. Like maybe one of these confidence scores down here where you got a different answer was actually going to be a lot better. And so there are kind of different ways of taking this based off of how much cost you're willing to give up.
Is it already built into the ChatGPT API and or LangChain to get this kind of perplexity?
Yeah, so you could probably go like right now and hook up our system into it. It would just be, I don't know if LangChain has a specific implementation, but it really wouldn't be that hard to code up like a few for loops and a few if statements that say, okay, well, can you like, because obviously the confidence calculations, the perplexity calculations are already built into LangChain. So long as you have access to a model like Llamas, where you can actually calculate these values, since it's open sourced, and you have access to logits at the end, you can then go in and kind of refine yourself and say, okay, well, here are the extra queries that I would need. And you can even log them and like look back at them later and be like, well, did this actually make sense? If not, you can maybe add in, a few extra more fine tuning on top of kind of this data set that the researchers have already produced. But yeah, totally.
Yeah. One of the cool things about this paper, from my perspective, is that it seems very easy to implement.
Yeah,
I would just like build a LangChain utility function for it, template. Yeah.
Yeah, and I'll go into this later on, but they also show that it's like really good at switching between data sets. There now, I'll go into this later, but like the data sets they switch between are quite similar in my opinion. But it is kind of interesting to see just how much better it does, or just how kind of impressive it does, which is I think you would kind of expect it to be able to switch between data sets quite easily, but it's definitely good to have like concrete knowledge there. Alrighty, so here's kind of our main performance table. What they have done is they have evaluated it on a bunch of popular single hop question and answer tasks. Here are the scores out of 100. They kind of range in how each test kind of calculates their scores differently in terms of what a correct answer is decided to be. For some, it's like they're essentially a four answer multiple choice question. Oh, sorry. Oh, question. And essentially some are like, okay, well, could you actually reason correctly about the answer? For others, it is just like, did you have the correct answers right? Did you say A? We don't really care about your reasoning for that. But kind of across the board, you can see that the refinement query rag actually does quite a bit better, especially compared to these like zero shot training Llama 2 models, whether it be like the non-chat or just the basic version or like the little bit of fine tuning with the chat module. And then even if you do this uh these like extra fine tuning with like actual single hop data sets, you can see that the refinement query still does a lot better. And compared to other state of the art or current state of the art uh popular like use cases in terms of RAG implementations like Sail and self RAG, it still does a few points better. And these are all significantly or to statistical significantly better. And then I don't know if might be, might not be. Next up, and I thought this was really interesting, was they compared to Chain of Thought, which I'm sure if people can kind of remember back, we've previously talked about this. And so they looked at performance on multi-hop question answer databases, and they found that again, the refinement query does quite a bit better as compared to all these open source models. And it actually does also a little bit better compared to GPT 3.5. It doesn't do necessarily as good as GPT-4. Again, that just shows just how important having all those extra parameters is. And obviously the fact that they've also been trained on so many more tokens. And also the power of chain of note, which is also another interesting way of kind of boosting your rack performance. Oh, and I also forgot to explain this, but multi-hop QA is essentially question and answer. They're very similar to kind of the last side where you essentially give yourself the LLM is given a question. It needs some type of information from the database to be able to answer this. Can it go efficiently go into that database and bring that information out? For multi-hop, all of these questions usually require multiple pieces of different databases. So it's like maybe you're asking a question about the movie Ford versus Ferrari, and you have all of the data of Wikipedia. You would need to go onto the pages of Ford, Ferrari, and probably like motorsports pages, or just like general motorsports competition pages to really be able to answer whatever question is being asked. Or if like there's specific persons coming up in that question too, you need to go into their Wikipedia pages as well. And so the question here is, well, can I actually properly decompose myself and disambiguate in these scenarios? And again, as it's clearly here at the bottom, they do quite a bit better than any type of other open source models that are available. Alrighty. Also, I kind of raised that they are quite resilient to dataset changes. As you can see here, they primarily used DuckDuckGo for all of the dataset creation, as I kind of talked back at the beginning of this talk. But if you switched it to Wiki or Bing search, you can see that they usually are able to about halve, a little bit, actually even a little bit more than halve the variance in terms of how much they're changing. And they still have a higher average performance across these three different QA data sets and evaluation tasks. Alrighty, thank you for coming. I think that's kind of the entire paper recapped. If anybody has like further discussion, I'd love to talk about it more, or any other points.
Red, our chief antagonist, is not here today. Yeah, I thought it was great. Again, I think it's really interesting because it's very easy to start using, I think. I think it's kind of a bold statement. Every paper that comes out says they're the best paper. And I was looking up how, whether those data sets that they evaluated on, are they very factually, is there correct versus incorrect answer for each of those, or how subjective are they? But I mean, even if they're in the same ballpark, that's really great. So
Yeah. And of course, like I think I have like an entire list. I keep going on. These are like all the data sets they use. And so you can have where is it, music Q? Like obviously that's kind of a more music-based data set where like you're asking more musically factual questions, but obviously even there's still a lot that you can kind of take each question, a lot of ways in which you can take each question. Also Open Orca, that's obviously a super popular data set, but the quality of questions in there ranges from like, factual math questions all the way up to more like opinion-based, kind of open-ended questions where you're kind of expecting some type of abstract response to solve some crazy problem that the researchers cooked up for it. But yeah.
Did they present any theories as to why they performed better than the other options?
Yeah. So let me go back to the first single hop. So the baseline here that they're talking about without retrievals, essentially they would compare questions where some of the data, like especially nowadays with like, oh, I went the wrong way, did I? Here we go. Is with just how many tokens that you're importing to all these models, especially like llamas, is like I think there's what short of a 300 billion to a trillion, I think, tokens when they trained the llama 2. So like huge data sets, and their background knowledge is just like kind of surpassed some of these old question answer data sets. And so often for a lot of these, they don't need retrieval. And so it's kind of interesting to compare just how adding even like you can see for the zero shot models, in fact, they go downhill when you add in just like very basic, no extra stuff retrieval, which kind of shows that if you do throw in RAG without actually telling the model like how to expect things, it will go downhill because you will just overwhelm it with information. But of course, that does depend on the data set. So you can see like for ARC, C it does do worse, but obviously for Pop QA, I don't know off the top of my head exactly how what the format of the questions are in Pop QA, but they're evidently they are easy enough that Llama 2, the most basic version of it, is able to do a lot better. And then they also are able to build upon. So refinement query is based. So self-RAG was the state of the art when the authors published their paper, and they are heavily based on self-RAG and also SAIL, except for the fact that for them, they have their own model doing all of this, whereas for self-RAG and SAIL, it's more of a black box between what it comes in on the query side and then what is outputted to the database. So kind of the refinement of the query for self-RAG is much more of a black box than what you get with refinement query, where you're very easily able to see at what steps, what is going on in the process that essentially gets me from like this starting query, which isn't very good, to what are all these branches that I went down to actually end up with this best query.
If you
And
had
kind of,
one,
yeah, maybe one last point there is probably again to be expected based off of kind of what we talked about with chain of thought, which is when you force these large language models to do their reasoning sequentially, even if it's just generating these queries and making them a little bit better, that definitely just again common theme here is that seems to be really what helps them the most.
I haven't seen a pattern for how these templates are developed. I can't tell whether they're just kind of chosen and kind of slightly crafted over time, or whether there's a more scientific method that goes into creating them.
Yeah, yeah.
If you had to pick one problem area for us to work on to apply this to, what do you think it would be most applicable to? It's our meetup.
Like I was like just looking at kind of our rack system when I was playing around with it yesterday. It was just kind of so interesting to look into scenarios where like I would ask it to draft like a welcome response and it would like confuse which hotel name I meant because I'd be talking about other hotels and then it should know like in theory based off of like my system prompt that I've told it this. And so like that would be a great situation there where like some amount of RAG might be appropriate. And this is like something that wasn't even covered in this paper, which is some amount of RAG might be appropriate, but can we ensure that we're not going in somehow confusing ourselves into thinking that I'm now talking about a different domain or a different organization than kind of what our chat history has shown.
Yeah.
I had a question here. So, is the intent behind the paper that you have this bigger model which is sort of capable of, all these sorts of query disambiguation and stuff like that. So you want to distill this knowledge down from a bigger model to a smaller model and maybe use that for like a production slash inference task when you're actually using it in like a rack system?
Yeah, so it's kind of twofold. So in these training examples, we're essentially trying to create a training data set to train your llama model on. You're relying on ChatGPT's kind of greater knowledge base to it'll be, since you're like going from, I don't know what ChatGPT had, like 175 million or billion parameters right now, down to, so like a 25% or 25 times fold reduction. In instances where you're like only skip when you're fairly confident about not doing so. When you reduce that, you'll end up in a situation where the llama model is actually pruning a lot more than the ChatGPT model in terms of you'll really be forcing it more so to look on its inside about its previous knowledge base, and versus whereas ChatGPT is kind of getting more of a crutch when it is able to, when it's kind of deciding to skip. Sorry, I didn't put that very clearly. What I'm essentially trying to say is that when you kind of reduce the number of tokens that it's seeing and the number of parameters it has, you're going to end up with a llama model that is skipping kind of more so than it should be, which is what you want, because you want to have a far more selective RAG program. And so by utilizing ChatGPT, which has this much greater knowledge base, you end up with a system which is far more aggressive in terms of its decisions. And so that's kind of a major reason for using ChatGPT. And then to kind of address the second part of it is also you don't have access to like the log hits, which is essentially like all of this lost data that you get at the very end of your model output. And so because of that, you can't have these beautiful ensemble approaches where you're essentially able to generate all these kind of different ways of looking at what did the user say to me. And you can generate out like maybe 20 different like paths down these trees. And you just don't get any way of guiding yourself, at least programmatically. You can maybe ask the LLM to evaluate, but when you're doing that, you're kind of just doubling down on whatever inaccuracies your LLM will have.
Mhm.
And so here you just get a very concrete values in terms of like your perplexity values or your confidence values.
Gotcha. And did the authors discuss anything around, let's say, were they using a single sort of vector DB or single knowledge source in the Stack pipeline, or is there an indication of how does the system perform when there are like multiple knowledge sources which are
Yeah.
asked to sort of go through to retrieve an answer or build an answer?
Yeah, so I kind of I maybe discussed this a little bit earlier, but yeah, so they mostly used DuckDuckGo. And their queries wouldn't even go to kind of a vector data space. Well, I guess DuckDuckGo probably stores their version of PageRank kind of in a whatever you would call it, vector database-esque kind of system for storing all of these pages when you type in some query to DuckDuckGo. But they were also able to switch it over to Wiki, which is obviously a far more factual database than you would get with DuckDuckGo. And also something that has like regular moderation, like Bing search, where you're kind of in between DuckDuckGo and Wiki in terms of at least what you would expect the quality of responses you're getting to be. And
Uh,
so they were able to essentially show
so
that when you were doing the switching, that you end up with a far smaller variance, at least compared to stuff like self-reg.
just to clarify, so the model is able to pick between either of the three depending on what the query was?
No. When they switched what the main
Okay.
input was, obviously they trained on DuckDuckGo, so it has like kind of a preference for having those as higher scores. But even when switching between Wiki and Bing search, which it wasn't even trained on, but are the ability to take in very similar or essentially, I guess the literal exact same queries, you really don't see a drop off in performance at all. It's slightly there, it is, as you'll see, but or like, yeah, I guess like if you even look at the OBEQI, you actually find that like using that factual data from Wiki really gives you a great boost in performance.
Gotcha. Thanks.
I got a question, and I apologize. I was only able to join at about 11:15, so I missed the beginning of the presentation. But can you talk more about the data set generation and
Yeah.
that process and how it can be, you know, I don't know, I assume like it's general, but how could you do it specifically for like one enterprise use case or something like that?
Yeah. So I think like if you were like, say you wanted to like start implementing this tomorrow, I think the first idea would be to first go get their database that they already created. Train your model off of that, see how well it does. Let it kind of keep running through a bunch of like question and answers that your users are giving you. Once you have a good kind of data set, I mean, you could probably just start small. Let's just say you're starting with whatever you have. Then you would, once you have, so essentially you're going to have like another injection point with like an X% of like your own proprietary data. You would then pass these queries that you're generating. So like, what other users are typing in that's like relevant to you. You would take these queries, pass them back to ChatGPT. You'd probably edit the system prompts here to regard a little bit more kind of what you describe more. Hey, this is actually what's in my database that you're actually going to. Like you can see they describe like where is it? Usually, yeah, a search engine. So like access to the entire internet, but you could like kind of switch out for a search engine and be like, well, here's what's in my database. You should expect information that's gonna be like this and stuff like this and this. And then you would just run these things again where you're going down, you're just letting ChatGPT go through and churn through your data set and essentially go from these really generalized queries to these very specific, really good queries. And then once you have that and kind of a list of what should happen, you then pass that on back to this new Llama model that they've trained up. Or maybe if you even want to scale up to something bigger. Again, this is a data set that you could do all the fine training yourself on. Obviously, they've already paid to do it, at least for one step of the way. But you could definitely scale it up. And then once you have all of that, you would now have kind of a more refined version for your data set that is able to kind of at different points decide which queries are appropriate based off of what it thinks it can find in your data set.
Thanks. And then I'm happy to play devil's advocate here in lieu of Red being on the call. So it seems like this process, resulted in some incremental improvements, but the cost, obviously you have a financial cost. There's increased latency as well, so it's going to take a little longer to get a response. And you're introducing more complexity with like you're hitting the internet, you're having it, think about the types of questions it's getting, and that introduces like errors in those parts as well. So for the actual gain in performance, do you think these drawbacks are worth it?
I think if you're solely looking on performance, you might say to yourself, I don't know if it is. If you really need to eke out those last few points, I think it is. I think where the real benefits, and I don't even think they really do a great job of kind of advocating this in their paper, but you end up with these far more conversational models that if you aren't just kind of trying to see, well, how do I do when I'm taking a multiple choice test? If you're looking more into, what do we have? These kind of disambiguation instances where you want to kind of take your queries that kind of have multiple ways of being answered. Can I do a better job of answering my users in fewer amounts and like in fewer amounts of them having to ask questions? Because it's not just about the time that like you're spending crunching out these numbers on your backend servers. It's also about the time that your users are putting in. So if you're able to get better responses to them quicker and also get them better insights, I think that's where your major benefits are. But obviously for that case, you would need to be something that's like very front facing and very you're very dependent in terms of what your users think are quality answers.
Can you go back to the slide? I think after this one. Oh, one more. Yeah, I'm wondering if it's a tunable value to determine how much it's outputting before or how much it's generating before returning a value to a user. So is it, you know, a full paragraph? Is it a sentence? Is it one single token? You know, if it's a paragraph, then you have to go through this whole process before you get back a paragraph. But if you go through with just a sentence, you know, then you get back a sentence pretty quickly.
Oh,
Again, did they talk about what that size is?
no, but I would imagine it'd be quite easy to kind of go through you just like apply a penalty at each stage. And essentially say, well, hey, you know, every time you do an inference, I want you to kind of in the same way you have like L1 and L2 penalties. You'd be like, hey, every time we're getting like another layer deeper here, you better be really sure that your next answer is going to be a lot better. If not, you're probably just like wasting our money in terms of you know, doing all these generations.
Yeah.
And that is something, yeah, that you would need to tune.
Yeah. They should make you an honorary contributor to the paper.
Yeah, I have a question about the labeling of the training data in particular. I might not have understood this correctly, so I apologize if I haven't. But it seems ChatGPT was used to label the training data.
Yeah.
If so, why not? Have they tested? I guess have they tested the system with just using ChatGPT as opposed to kind of to make decisions as opposed to using sort of a trained model?
Yeah, so that's kind of what self-RAG does is they go through and I think that I have comparisons to it over here. It's much more of a black box where essentially you give all of your stuff to ChatGPT. It goes through, it generates a prompt or sorry, it generates a query that it thinks is a lot better than it's more specified query that it thinks is a lot better and then gives it back to you. Their major comparison was that, well, hey, doing it our way. First of all, we see like some incremental improvements here. Again, not great. When you get the multi-hop, it gets a lot better. It also gets a lot more complicated in terms of those comparisons. But at least as far as single hop goes, we get some small increases in terms of performance. But even more so than that, like when you're going back and you're looking at, okay, well, what actually happened in my whole chain of what was going on, I can very specifically see what the reasoning was going through in terms of like the LLM's head when I have this data labeled and then I'm able to have it, my new llama model that's been trained off of this to refine queries, go through it. You can then look back and be like, oh, did I just give out like a terrible answer that was like detrimental to a customer? Well, now I can go back and kind of see where I went wrong. Whereas as far as ChatGPT goes, all you know is that something was wrong your system prompt that you gave to ChatGPT to refine the query, but you know you only have that one element of one element that you're able to look into in terms of, you know, what is the postmortem, where did this go wrong? Whereas here you can be like, oh, okay, it was specifically in this step. I don't know why I disambiguated here. This was like we already had access to this information in our database. You know, clearly I just need to tune it a little bit here and be like, oh, well, also don't forget about this information that's also in your database. If you get to this point, you know, you should just like cut everything off there and answer because you already have access to that information.
Got it. Cool. Thanks.
Any more questions? I'll do our outro here. So Alex is presenting next week. He is going to go over some of the new tooling related to having multiple LLMs talk to each other. I think one example is Crew AI. Peter, you were the one who actually suggested that, so that's great. But a lot of new tools coming out around that. I think that'll be very applicable. And then Jason, you're Jason Nichols, the CEO of VeronFast, former director of AI at Walmart. Did you pick your paper yet?
Yep, just emailed it to you.
Oh, excellent. Fantastic. And then week after that, we have Jisong, ML signals engineer at Pinterest. He's gonna be presenting as well. So yep, that's it. Any shout outs or requests, offers? Okay, everyone have a fantastic week.
Thanks, guys.
Thank you.
Thank you, Julian.